compound interest formula problems. So this is a question where you have to figure it out the time that is required for $3,000 to double invested at 6%. So there's two parts of this question. 6% is compounded annually, which means once per year. So this is part A. So this is one time per year. And then compounded daily, which means 365 times per year. So the compounding period plays a very significant role. The more frequent that is, the faster will be the growth. But we have to come up with $6,000 in order to double it. So the time involved will be different. So let's see how long will it take if the interest rate is compounded once per year. We will use the same formula for both cases. So the amount is equal to principal 1 plus the interest rate to the power of n. So this time n will be measured in years. So the amount, including the interest rate, will have to equal to $6,000 in order for you to double. P is 3,000, and the interest rate is 6%. So 1 plus 0.06. How do we know that? 6% converted into a decimal is equal to 0.06. Okay, to exponent n. Simplify as usual. So divide both sides by 3,000. You're going to get 1 here and 2 on the opposite side. Now we have to simplify further by writing the following. So I have to show that there is a 2 here, and the right side is 1.006. Wait a minute. No, 1.06 to the power of n. To find the value of n, use logarithms. So log to base 2, any logarithm will be fine. So we can use log to base 10 because that's the one available in our calculator. Natural logarithm also would be fine. By the product rule, by the power rule rather, n will be taken outside and you have log of 1.06. To find n, you will see that this is about 11.895. Now, you have to understand this is calculated once each year. So in our case, we will have to wait about 12 years because 11 years is not enough. It's closer to 12 and at the end of each year. So you have to count total number of whole years. Okay, so 12 years. So that's the time for you to increase twice as much. Now, interest rate compounded daily. So this is part B that we have to work with. So 365, there are 365 days in 1 year. So the interest rate, 6%, has to be divided by 365. So the formula will be identical. The meaning of I will change. So now the interest rate will be the adjusted interest rate when we divide yearly interest rate by 365. The exponent n also will be measured in days. So the left hand side will be 6,000 because we need to double the amount. So 3,000 is the value of the principal, 1 plus. So when you divide 6% by 365, you will get rather very small decimal number. So 3 zeros and then 16438. 16438. So exponent n. I strongly recommend that you use as many decimal numbers as possible, as many digits, I would say. Should you choose to cut this number short, you will have a very different result. So to get accurate reading, I want you to spend time when you divide 6% by 365 to select significantly long number after the decimal point. So, same procedure. You divide both sides by 3,000, so the left side will be 2, the right hand side will have 1 point, and then copy those numbers. So 3 zeros, 1, 2, 3, 16438, 16438 to exponent n. As in the previous part A, we will log both sides. So log 2 is equal to log. So what will happen with that exponent? It goes out and log this long number. 16438. 16438. Okay, now n. Number n, when you divide log 2 by that logarithm of this 1 point, very small decimal number after, you will see, if you do use long enough decimal number, that you will get 4,216.99, about 4,270 days. But we're not going to say that for the value to double, you have to wait 4,217 days, because that number does not really mean much to the average person. You would have to convert into years and then remaining days. So 365 goes into that 11 times, so 11 years, and the difference 202 days. So this is the time that is needed to double $3,000. So when you compare this finding with that, you'll see that it takes shorter when the interest rate, when the compounding frequency is greater. So the faster you evaluate the interest rate, the less time is needed for you to grow to the same amount. And that makes sense. So I hope you have watched this video with pleasure, and I believe that you have understood the concept of compounding interest rate. Thank you very much for watching, and I'll see you next time.